All right, back with yet another practice test video. This is test 12. The 1 and 2 say graph the function, identify the reference points, underline that for you, and draw the graph, tell domain and range. Remember, E is really 2.71828, so it's really exponential growth because E is bigger than 1. So the graph will always go this direction, or if it's the number 2, it's got a negative in the front, so it's been reflected. Asymptote has been shifted up 3. It's usually x-axis has been shifted up 3. Your point that you usually start with is always 1 above, but because it has a x plus 1, it's been 1 above, shifted left 1. The next point we pick, always go right 1. In this case would be 0. Plug it in up there. They'll give you e to the first power, which is e plus 3, so that's it right there. When you graph it, remember e is like 2.7, so you do 2.7 plus 3, which takes you to 5.7. And then you can just connect that, dots, la la la. Domain is always that. Range is above 3 because that's the asymptote, and that's number 1. Number 2, same kind of problem. Asymptote is down at negative 2. This time, instead of going up 1, I'm going to go down 1 because it's a negative in the front. Because there's an x plus 1 in the exponent, you also shift left 1. So you go down 1, left 1. Pick the point 1 to the right, which is a 0. If you do that, you get negative e to the first power, minus 2, which is really negative e minus 2, which is what I'll write right there. So to figure out where to graph that, remember negative e is with negative 2.7 minus 2, which is like negative 4.7. Then you connect your dots, put your domain and range. Number 3, you got to go backwards. The greatest thing about doing the e graphs backwards is your second point they give you right there is going to have your equation in it almost. So it says 5e plus 3. It's been shifted up 3. You got the 5e. That's all good. The only thing you got to figure out is what goes with your e, what exponent does. Remember, your point is supposed to be on the y-axis. This point has been shifted 2 to the left from the y-axis, so I had to put an x plus 2. Gosh, excuse me. Wow. And that's all you do on that one, except don't forget to tell your domain and range. Don't miss a point because you forget your domain and range. Number 4 also goes along with that same day. They give you the equation of the problem. Don't forget that n of t means the final amount. That n sub 0 means the initial amount, or how much you started with. And e is just the e with that exponent. So down here you find out what the initial was, what the final amount was. To solve it, divide both sides by 300. Then it gives you this, and because you have an e, and you need the exponent. Anytime you need an exponent, you need to do a log of both sides. And because it's an e, you're going to do natural log of both sides. You punch in ln of this side. Remember, the exponent goes in the front. Ln e is just 1. And you get a natural log of 0.08. So to get your answer, just do that natural log divided by negative 0.1155. So you get 21.9. Number 5 through, I guess, 8 or 9 is just going to be interest problems, all a little bit different. This first one just says annual interest, no compounding. So, no compounding during the year. So, what you end up, there's your formula. I'll give you that formula tomorrow on the board. What you end up with is over here. What you start with is the principal here. 1 plus the rate. There is no n this time to the t power. So what I did is I divided both sides by that. I added those two and got 1.064. And because I need the exponent, you got to do log both sides, which I did. The exponent goes in the front. So just divide that log by that one, and you should get 12.4. 6 is the same way, except it's compounded continuously. Whenever you see the word continuously, you use PERT, the PERT formula, PE to the RT. Over here is what you end up with. Here's what you start with. E, rate, those there. It's this 5%. Change it to 0.05. T power. Divide both sides by 2550. You got that decimal. Because I need the exponent, you got to log both sides. Because it's an e, I'm going to do natural log of both sides. So I'm dividing, that natural log of e, remember, just basically cancels because it's 1. I'm dividing the natural log on that side, divided by the 0.05, and get that answer. Number 7, back to the original formula, because it doesn't say continuously, it says daily, which means n is how many times per year. Since there's 365 days in a year, n is 365. So I'll put that in there. The final amount, the initial amount, r, the rate over n, and up here the nt power. So I did 2 things. Actually, that's where we stopped in class. I didn't finish it. I don't have my calculator. So what I would do here to finish, sorry about that, we'll do it in class if you want to tomorrow. I divided both sides by 9,000. That's when the bell rang. I need to add those together right there, and see what it equals. Still have the exponent, and because I need the exponent, I would do log both sides. So I'm going to do the log of this divided by the log of the parentheses. But I would still have the 365t, so I'd divide again by 365. That would give me my answer. Sorry about that. The good thing is 8 is just like 7, except it's the n is 4 instead of 365. So you do it the exact same way. The final amounts here, initial amount there, there's my parentheses, the rate over n, and then nt. Those two numbers are always the same. Okay, here I go. Divide both sides by 1400. Add the parentheses. That's right. This shut off last time. It's right there to the 4t power. Because I need the exponent, you do natural log both sides. So, I'm sorry, log both sides. So you do log of this number, log of that number. The exponent goes in the front. Divide the two logs and get 40.86. Then divide by 4 because you got 4t. And there you go. So 4 through 8, or 5 through 8 are all the interest problems. Number 9 and 10 are the finger thing, just practicing those. Remember, you're going to write the log in there. That's the base. Remember that base to that power equals 216. 6 cubed is 216. That's all you got to do. Number 10, to go backwards. 6 to the b power is a. That's what I wrote. 11, they're telling you what to plug in for your x here. So the first thing you do is log base 4 of 16, which really means 4 to what power 16? 4 to the second power. 4 to what power is 1/64th? The -3. Remember, don't worry about the fraction. Act like the fraction is not there to get your 3. And because it is a fraction, you have to flip it or do reciprocal. So that means you got to put a negative exponent with it. And the last one, again, ignore the cube root for a second and think 4 to what power 16? 4 squared is 16. That's why I put the 2. And remember the old gesture we did about bottom is the root, top is the power, bottom is the root, top is the power. Because it's a cube root, I got to put a 3 on the bottom because it's the bottom is the root. 12 is the easiest one on the whole test. Don't you dare think about missing that one. It says find the common log and natural log of 0.81. So all you do to get your answer there, the first answer, you just punch this in. You take your calc, go log 0.81, and you're going to get that number right there. The second answer, you do natural log natural log of 0.81, and you get that answer. It's about to write the answer over there. That's all you do. Make sure you go 4 decimal places. 13, 14 says a lot of stuff. It's a lot of directions. It's not a hard problem, but there's a lot of stuff you got to put. First thing it says is identify. So I went through it. There's a negative that reflects across the x. There's a 2 that's a vertical stretch by 2. There's a +1 that's a shift left 1. There's a -2. I went down 2. This is what we did in class today. All right, so here we go. We've got a -2. Asymptote gets shifted left 2. Remember, we always went over 1 to get our point right here. When you go over 1, just look right here, the last number. Oh, it says down 2, so you go over 1, down 2. There's your first point. So go ahead and, if you want to, write it down there, 0, -2. To get your next point, we're going to make the parentheses be whatever the base is. That time the base is 2, so I'm going to put in a 1 for x. Look right here, a 1 for my x right here. And when you do that, the log becomes 1. So you do 1 times -2, which is -2, minus 2, which is -4. So I went to 1, -4. There's another point. Connect the dots, la, la, la. You got it. Don't forget your domain and range. A lot of writing on that one. 14, 3 in the front, vertical stretch by 3. Shift left 1, shift up 2. So I take my asymptote, go left 1, because I had a +1 there. My first point's to the right 1, but because there's a +2 out here, I'm going to go up 2 to right there. The second point, my base right there is 2. I need the parentheses to be 2, so I'm going to plug in a 1, which is my x. If I plug in 1 up here, that means the log is 1. 1 times 3 is 3. 3 plus 2 is 5. There's my other point, 2, 5. There they are. Sorry, 1, 5. 0, 2, and 1, 5 are my 2 points. Don't forget your domain and range. Hopefully that got better as the day went on today. I know we struggled for a little bit early, but I think by the time we were finished up, you were doing really well there. Okay, this section right here, you're just going to tell the changes that would happen to the graph if they do this. So there's a shift up 3. And think about what that changes. If you shift the normal graph, and this is not a bad idea to do this, that normal graph, will cross at 1 and would go like that right there. If you shift it up 3, the domain doesn't change, the range doesn't change, the end behavior doesn't change, the asymptote doesn't change. The x-intercept does though, because your x-intercept is now up 3 where it used to be, so it's going to change that some. Still increases and the whole way, so no change there. So the only thing it changes was the x-intercept. This one has a 3 in the front, which means there's a vertical stretch. And what that does is it stretches, it makes it steeper. It doesn't change the 1 or anything. So I started thinking through the changes. Does the domain change? No. The range doesn't change. The end behavior doesn't change. The asymptote doesn't change. The x-intercept doesn't change. It's still increasing. Nothing changed at all. and that can happen. So if you remember that, tomorrow if you see one that just says vertical stretch, there'll be no change. If it changes up like that, the one that'll change the most is if you have a left and right shift. 17, 18, let's see here. Say the domain range. This is what we did last week. Look, if you look at this, this is guys, this is the same thing as number 1 and 2 on this test. Number 1 and 2 had e's. These have a number. Remember, e's is 2.7. This is 3. All right, so I'll draw my asymptote right at well, down 1. So I draw it. I'm with the -1. Usually I'd come up 1 right there. This time though, because there's a 2 in the front, I've been stretched by 2, so I'm going to go up 2. And because there's a 2 in there, I'm going to go left 2. So my first point is right there. I went up 2, left 2, which puts me at -2, 1. I went ahead and wrote that point down right there. And remember, I always go 1 to the right. If you go 1 to the right, that makes it be -1. If I put a -1 in there, the exponent is +1, which makes that just 3. It will always just be that number. 2 times 3 is 6. 6 minus 1 is 5. So you go -1, 5. Connect your dots. Don't forget your domain and range. 18, same way. Asymptote is up at 2. Usually I'd go up 1, but because there's a negative, I'm going to go down 1. And because there's a 2, I'm going to go down 2. So, and because there's an x -1, and I'm going to go right 1. So down 2, right 1. There's my first point. To get the next point, go 1 to the right, which puts you at 2. 2 makes the exponent 1, makes that a 3. 3 times -2 is -6, plus 2 is -4. There's my point. Ta-da. Don't forget to write your points out there. 19 is a weird one. 19, square both sides. If you do that, you get, don't forget to square, multiply, double, square. Over here, the square root just goes away. One more time, square, multiply, double, square. If you move the x over here, you get -5x. If you move the -6 over there, you get +10. I can't factor that, so I tried quadratic formula, and I got a negative inside. And because I did that, because it's radical, you can't have i's in a radical, so that means there was no solution. Guys, 19 is the exact same problem on your test tomorrow. Just saying. Number 20. Number 20 is square both sides. If you square the left-hand side, you get x -7. If you square the 6, you get 36. Just move the 7 over. Don't forget, it could be extraneous. So check it. Plug the 43 back in. It works. 21, 22. We had some of these last week also. Remember, if you see a square root and ask you to graph it, it's half of a sideways parabola. It's got a negative in the front, so it's going to go down. It says +3, so you're going to start at 3. There's nothing in the front, so you go down 1 over 1 to right there. Draw your graph. Tell your domain and range using set notation. Your domain and range are both going to come from that point. The x coordinate's 0, the y coordinate's 3. Look what we have here. You need an equals 2 with your set notation because it does touch the point. Same thing here, going left 4, down 1 for my first point. Now, the 1/3 in there is a horizontal stretch by the reciprocal. So instead of going over 1, up 1, you go over 3, up 1. Connect the dots, la la la. Do your domain from your initial point the same way we did on 21. 23, a bunch of factoring. This was actually on last week's test. Factor the top of that one, which I took a 3 out. Factor the bottom. This one you got to flip because it's division, so difference of squares on the bottom. On the top, take the 12 out, which is now the bottom. Now, factor the rest of that. So I'll factor the rest of the top. This is the difference of squares down here, so I can factor the rest of it. Then start canceling stuff. A plus 1s cancel. A plus 2s cancel. 3 and 12 cancel. So what that left me with on the top is an A plus 1 and A minus 2. On the bottom, I have a 4, an A minus 5, and an A minus 1. All right, last page finally. So 24, we have one of these just about every single week. I made a list. I didn't show it. Punch in your calculator, see where your graph crosses your x-axis. Look for your x-intercept. I noticed it was at 3. So I put a 3 in the box. It worked out perfectly. I got a 0 down here, and it left me a 1 and a 0 and a 4. Because this started with x cubed, this starts with x squared. X squared plus 4. Set that as an equation. Move the 4 over. Take the square root of both sides, and you get plus or minus 2i because it was negative. Now, when you write your answer, because it was degree 3, you need 3 solutions. 2 solutions are plus or minus 2i. Don't forget your first answer, which was 3. 25, not bad at all. Take the 3x all the way through, and when you do that, you get those 3 numbers. Take the 2 all the way through, you get those 3 numbers. Then add what you can and get your answer right there. And the last one, 26, expand this thing right here. Because the exponent's 4, you're going to get 5 terms in your answer. You start out by doing x to the 4th. You end up doing 4 to the 4th. So there's 2 of your 5. The second one always starts with your main exponent, 4. Your x's start going down. your 4 starts coming up. So that's 4 to the first power. To get this 6 right here, I did NCR. Remember, N is 4, R is one of these two exponents. So I did 4 NCR2, punched it in, got 6. Your X's go down, your 4 comes up. Your X's go down here, your 4's come up. Because that's a 1 and a 3, and this is a 1 and a 3, because that was a 4, that's a 4, and that's all my terms. Now, don't leave it. Some of you are still leaving your answer like this. Multiply stuff out. Bring the first term down. That's a 4, that's a 4. 4 times 4 is 16. On this one, that's 4 squared. That's 16 times 6. That's 96x squared. That's 4 cubed, which is 64, times 4. That's 256. That's 4 to the 4th, which is 256. And that's it. Hopefully it helps. Watch. I'll let you skip around on this one. Watch as much as you need to, which means some of you needs to be a lot. And I'll take some questions in the morning, but be ready, do good. See you tomorrow.